Hi, my name is Nasa P. de los Reyes, and I'm a student from STEM-B. Today, I'm going to be discussing to you the basic integration rules of integral calculus. There are 5 basic integration rules, and they all follow a certain pattern. Here are some of the rules. The indefinite integral of a constant, the power rule, the sum and difference, the indefinite integral of the function x raised to -1, and the indefinite integral of the exponential function. Let us go ahead and delve deeper into the first rule, which is the indefinite integral of a constant, and it is denoted by this equation. The small letter k is called a constant, and a constant is defined as a fixed value or any value that cannot be changed. The examples are fractions, whole numbers, and radicals. Let us go ahead and solve the first problem where we could apply the first rule. This problem can be read as the integration of 5 dx. In order to solve this, all you have to do is find the value of letter k, which is 5. And then, using the equation kx plus c, go ahead and substitute the value of letter k with 5. So now, we have a final answer of 5x plus c. There's also a second way in order to do this. Simply go ahead and write down the value of letter k first, which is 5, then add the x plus c right next to it. So both procedure came up with the same answer. The second problem is the integration of 5 over 6 dx. Go ahead and find the value of letter k, which is 5 over 6. And then, using the equation kx plus c, go ahead and substitute the value of letter k with 5 over 6. So that is the final answer. You could also do the second procedure, which is writing down the value of letter k first and then adding the x plus c right next to it. So both procedure came up with the same answer again. Now, what about this third problem? We have the integration of square root of 2 dx. In order to solve this, all you have to do is find the value of letter k, which is the square root of 2. And now, using the formula kx plus c, go ahead and substitute the value of letter k with the square root of 2. Now, keep in mind that the x plus c should never be considered as a radicand. It should be placed outside of the square root symbol. Now, we have a final answer of the square root of 2x plus c. You can also do the second procedure, which is writing down the value of the constant first, which is the square root of 2, and then add the x plus c right next to it, which is going to be the square root of 2x plus c. Always make sure that if you're going to be solving for radicals, do not put the x plus c inside the radical. The second rule, or also known as the power rule, is denoted by this equation. The power rule focuses on exponents, and exponents are denoted by the letter n. You would always need to make sure that n must never be equal to -1, or else you'd get an undefined answer. Now, this is the problem where we could apply the second rule. The problem can be read as the integration of 3x squared dx. All we need to do is find the value of the exponent, or the letter n, which is 2. And then, go ahead and write down the problem once again, which is the integration of 3x squared dx. We need to make some adjustments here. What we need to do is, if ever there is a constant inside the indefinite integral, you will need to take that out. Simply go ahead and switch the position of the constant and the integral symbol. So now, what we need to find is the integration of x squared dx, not the integration of 3x squared. And I can solve it simply by using the formula at the top. Go ahead and add +1 on both the n on the numerator and the denominator, and then we would come up with this answer. Now, simplifying it, go ahead and take out the 3 on the numerator and the denominator, so our final answer will be the x cubed plus c. Hi, today we're going to be discussing the third rule, which is the sum and difference, and it is denoted by this equation. The sum and difference focuses on separation or separating. Now, here is an example where we could apply the third rule. The problem can be read as the integration of 2x squared plus x raised to 4 dx. All we need to do here is we need to separate the 2x squared from the x raised to 4. So now, we need to find the integration of the 2x squared dx plus the integration of x raised to 4 dx. Now you can see in the integration of 2x squared dx, there is a constant inside. So we just need to do the same thing as we did previously. We need to take that constant out, and we need to do that by switching the position of the constant in the integral symbol. Now you can find the integration of both the x squared dx and the integration of x raised to 4 dx. That is done by simply applying the power rule by adding 1 on both the n on the numerator and the denominator. And now we have an answer of 2x cubed over 3 plus c plus x raised to 5 over 5 plus c. Now you can see that there are two c's in the equation. This can be done by simply removing the other c and just adding 1c. So now, it can be written by 2x cubed over 3 plus x raised to 5 plus c, or 2 over 3 x cubed plus 1/5 x raised to 5 plus c. Hi! Today we're going to be focusing on the fourth rule, which is denoted by this equation. This rule emphasizes the function x raised to -1, which can also be written as 1 over x. We need to make sure that n is never equal to 0. Here's an example where the fourth rule is applied. This problem can be read as the integration of 3 over 7x dx. What we need to do here is we need to separate a few things. And that is, we need to separate the 1 over x from the function 3 over 7x. Based on the equation above, in order for us to solve it, we need to get 1 over x dx, so we can get the value ln absolute value x plus c. Now we have two items, which is 3 over 7 and 1 over x. Now what we need to do, since there is a constant in the indefinite integral, we need to take that out by moving the position of the integral symbol, or the constant. And now, what we need to get is the integration of 1 over x dx multiplied to the fraction, or the constant. Now, we have a value of 3 over 7 multiplied to ln absolute value x plus c as our final answer. How about this second problem that we have, which is the integration of 2 over x dx. The same thing is also applied. All you have to do is you need to take out the 1 over x from the function 2 over x. So that is why we would need to separate the 2 from the function 2 over x. So now we have two items, the 2 multiplied to 1 over x. What we need to do here, since there is a constant, we need to move the position of the integral symbol, or the constant. Now, what you need to do is you need to get the integration of 1 over x dx multiplied to the constant. So our final answer will be 2 multiplied to ln absolute value x plus c. Hi! Today I'm going to be discussing to you the fifth rule, the last rule, or also known as the indefinite integral of the exponential function. It is considered as an exponential function if the variable used is letter e. Here is an example where the fifth rule is applied. This problem can be read as the integration of 25e raised to 5x dx. In order to solve this, we would need to find the value of letter k, which is 5. Then, we would need to rewrite the problem, which is the integration of 25e raised to 5x dx. Since there is a constant, we would need to take it out. What you need to do is you need to multiply 25 to the integration of e raised to 5x dx. So now, the constant is being multiplied to the integration of the exponential function. Replace the value of k with 5, and now you would need to multiply it. We would come up with this answer, which is the 25 over 5 e raised to 5x plus c. Now, you would need to simplify this, And our answer will be 5e raised to 5x plus c. Here's a summary of the basic integration rules. Hi! Thank you all so much for watching this video, and I hope that you learned something.